If you've ever found yourself wrestling with a mountain of complex SQL joins just to analyze connected data, you know the pain. Well, today, we're going to dive into the world of Cypher and see how its graph-based queries can solve these exact problems, but in a much more elegant way.
So think about this for a second. It's a classic problem, right? You want to find connections that are 3 steps away. In SQL, where do you even begin? The query gets complicated, and it gets complicated fast. And this slide just nails the difference. On the left, you've got the SQL approach, joining the same table to itself again and again. It's clunky, it's hard to read, and it just gets worse the deeper you need to go. But then look at the right. Cypher expresses the exact same idea with this clean, visual pattern. It literally looks like what you're asking for. Find a path of exactly 3 steps. It's that simple.
That's really the power we're going to unpack in today's explainer. We're moving past the basics to see how Cypher's approach, which is native to graphs, gives us a way better way to handle these complex, connected data challenges.
So we'll break it down into 3 key areas. First, searching for connections when you don't know the exact distance. Second, how to handle real-world, messy, incomplete data. And finally, a much smarter way to group and aggregate your results.
All right, let's jump into our first superpower, finding connections across unknown or flexible distances in your graph. This is where we really start to leave that whole world of rigid table joins in the dust. Then the core idea here is something called a variable length path. See, instead of telling the database to find one specific direct link, you can ask it to find any path within a certain range. You could say, show me everyone between 2 and 5 steps away. That kind of flexibility is an absolute game changer for network analysis. And the syntax for this, it is just beautifully simple. All you do is put an asterisk in the relationship brackets, and it opens up all these options. You can specify an exact depth, like *2 for your classic friends of friends. You could set a maximum, like */4 for anyone within 4 degrees of separation. Or you can even define a super specific range, like *3.5. You get this incredible precision with almost no effort.
Let's make this totally real. Imagine you want to find every company connected to IT Corp, whether they're direct partners or partners of partners. Instead of writing 2 different queries and then trying to merge the results, you just write -*2.key -*. In one single line, you've perfectly described your immediate business circle.
But what if you don't need all the paths? What if you just want the most efficient one? Well, for that, Cypher has the shortest path function. You know when a social network shows you how you're connected to someone? This is pretty much exactly how they do it. It finds the most direct route between any 2 points in your graph.
Okay, on to our second topic. Finding paths is awesome, but let's be honest, real-world data is almost never perfect. So what happens when some of the connections you're looking for just aren't there? Well, Cypher has a really elegant way to handle this super common problem.
Now, if you come from an SQL background, this slide is going to make things click instantly. A standard match in Cypher is basically like an inner join. If any piece of the pattern you're looking for is missing, that whole row just gets thrown out. But optional match, that's your left join. It always keeps your main data and just fills in any missing bits with null.
The logic behind this is so powerful because it's so simple. First, Cypher tries to find the complete pattern you asked for. If it finds it, awesome, you get all the data. But, and this is the magic part, if it fails, it doesn't just give up and drop the row. It keeps what it did find and just gracefully tells you what's missing. The result? You never accidentally lose data. So here's the before picture. Let's say we run a query to find people in the companies they work for. If we use a standard match, anyone who doesn't have that works-at relationship just disappears from our results, vanishes. Suddenly our list is incomplete, and honestly, it's pretty misleading.
And here's the fix. It's so simple, but so powerful. We just change match to optional match. And just like that, we get the whole story. All the people are still on our list. For the ones who are employed, we see their company. For those who aren't, we see null. Our data is now complete, it's accurate, and nobody got left behind.
All right, for our third and final section, let's talk about data grouping and aggregation. This is another one of those areas where Cypher makes a common task, especially preparing data for an API or an application, so much more intuitive.
Okay, so the key thing to wrap your head around here is that Cypher doesn't have a group by clause like SQL does. It doesn't need one. Instead, the grouping is implicit. Whatever you put in your return statement that you don't wrap in an aggregate function like count or sum, that automatically becomes your grouping key. It's a simple rule that just removes a whole line of code you'd normally have to write.
So let's look at a classic problem when you're getting data ready. We want a list of companies and their employees. A simple query might spit out a result that looks like this. You get multiple rows for IT Corp, one for each person who works there. For an API, this is just messy and inefficient.
And this is a real-world headache. Trust me, your front-end developer is not going to be happy with data formatted like this. It forces the application on the other end to do a bunch of extra work, looping through everything just to group it all back together. It's a waste of time and processing power.
Now, Cypher has all the standard aggregation functions you'd expect to see. But the one I really want you to focus on here is collect. This thing is a genuine superpower for shaping data. It takes values that would have been on separate rows and bundles them all together into a single list or an array right there in your query result.
And would you look at that result? It's beautiful. By using collect employee, we take that messy table and we transform it into this perfectly structured API-ready object. We get one clean row per company with a neat little list of employees right there with it. This is exactly the kind of data an application loves to receive.
So let's step back and bring this all together. What we've looked at today isn't just a handful of clever functions. It really is a fundamentally different and, I'd argue, more intuitive way to think about and work with your data. So let's quickly recap the 3 big wins we covered. First, Cypher lets you search incredibly complex paths with simple visual syntax, letting you escape that join nightmare. Second, it handles messy, incomplete data gracefully, using optional match, so you never lose sight of the full picture. And finally, it lets you build perfectly formatted API-ready data right in the database, using collect, saving a ton of time and effort down the line.
And this, right here, is the most important takeaway. Adopting these Cypher patterns isn't just about learning new commands. It's about shifting your mindset to think about your data in terms of patterns and relationships, which for a lot of real-world problems is just a much more natural and powerful way to model things.
And so that leaves us with one final question to think about. With tools this powerful for exploring connections, for handling imperfections, and for shaping your results, what hidden patterns and incredible relationships are just waiting to be discovered in your own data? Thanks for joining me.